Flywheel is a medical imaging AI platform that offers tools aimed at helping researchers streamline data ingestion and curate BID's standardized datasets for accelerated AI development. Flywheel is being used to manage shared datasets at multiple aging and disability resource centers in collaboration with the National Alzheimer's Coordinating Center. Today, we will go through an example of an Alzheimer's study on the platform that involves gathering brain MRI images and filtering images by file type, age, and test scores. Then, with the data we have filtered, we will look at tools to help readers score an AI model being trained to detect brain atrophy. To start, we will go to Flywheel Discovery. Flywheel Discovery indexes information from your clinical PACS system that allows you to easily identify a cohort of subjects. There are many filters we can customize according to the metadata we have about our data. Here, we will filter by MRI images of different regions. We will choose the brain. Next, we can filter further to find a cohort of scans from the same equipment manufacturer to control for scanner protocol. We can easily drag to select imaging studies within a specific set of dates and submit a request to add the cohort to our project. Now, we will supplement our existing dataset with open access datasets that have already been curated for us in Flywheel's Data Exchange. All datasets have enhanced metadata and are ready for further analysis. First, I will search for brain images and filter by results for MR modality. First, we can review the distribution of key demographics in our dataset before importing it into our Flywheel project. After populating our Alzheimer's project files with data from our PACS and from the Exchange, we will investigate some of the data we have imported more closely using Flywheel Search. Basic Search allows you to easily filter the relevant subjects or imaging datasets with key parameters such as file type, modality, classification, and subject age. Here, we will look for subjects with T1 MR files over the age of 40. With Advanced Search, we can filter even further with unique queries according to any variables we have recorded and indexed. By leveraging this metadata, such as slice thickness value, we can create a unique collection of images according to our research question. We can look at all custom metadata and files attached on their imaging records. We can see that our subject has cognitive test scores documented along with the date of their study enrollment. We can launch the scan in the viewer to begin reviewing. We can see that this session has a number of medical imaging files that are grouped into acquisitions. We have several brain scans, including structural and functional images. After inspecting the first batch of data as is, we can set up a pipeline of data curation steps to make sure we are optimizing the usability of these images. We can automate this series of curation steps through a function called gear rules. In this example, I have pipelined a DICOM tag extractor, a file classifier, a conversion script to generate nifty files from the original DICOMs, and an MRI quality control script. We also offer additional curation workflows out of the box for neuroimaging researchers to leverage, including a curator for the brain imaging data structure. Once the pipeline is run, we can review quality control outputs and tag the data for downstream analysis. With our data curated, we can set up relevant reports that we will run throughout our study. In Flywheel, we will use the Data Views feature to set up demographics reports and cognitive test score reports. These reports will provide a real-time view of data we're including in our project. Now that our data is aggregated and processed, we are ready to train and tune our model. Flywheel offers a solution for orchestrating reader studies with features to manage reader tasks to generate ground truth data or human-in-the-loop model tuning. In this example, a radiologist is reviewing a model aimed at detecting cerebrospinal fluid around the brain to determine the amount of brain matter loss or atrophy in this Alzheimer's population. The radiologist can make their way through a task list and provide feedback in the viewer form. The study administrator can then review all radiologist answers and the level of reader agreement and make a determination about the next steps for model refinement. Now we will evaluate an imaging pipeline to quantify the relative standard uptake value of amyloid or tau proteins in specific brain regions. The pipeline can be launched at the project level, and the data can be further analyzed using a Jupyter Notebook workspace. In this notebook, we see that we've converted our data into tabular format, so we can plot uptake values or create parametric maps on cortical surface or subcortical areas. In this demo, we've shown you how to find data, prepare it for use in advanced analytics, and then see results that are relevant to your patient's disease states. This short demo is a sketch of what can be done in Flywheel. To create a fuller picture, we invite you to contact us to explore how you could use our platform to manage neuroimaging and associated data.